Okay, this is question 7 from worksheet 4 in unit 3. Question 7 says, if the same quantity of energy was removed from 40 grams of water vapor at 100 degrees Celsius, what would the final temperature of the water be? Well, this is referring back to question number 6. So, in question number 6, the answer that you should have gotten was 104 kilojoules. So that's the amount of energy that this problem is referring to, is 104 kilojoules, which is 104,000 joules. And the first thing I need to do is construct my graph. And so I'm going to look up here and figure out like what I'm dealing with. Well, I have water vapor at 100 degrees Celsius. And the question implies that I'm removing energy, so the temperature is going to go down. And it refers to the temperature of the water. This tells me that if I start with water vapor and I'm being asked about the temperature of the water, that I'm going to have a phase change. So that's going to help me when I'm drawing my graph. So let's start with that. My initial temperature is 100 degrees. And this is time. So I'm going to undergo a phase change at 100 degrees. It's going to start as water vapor and it's going to condense down into water. And then the temperature is going to go down. And I don't know how far, I don't know where it's going to stop. So that's what I'm going to be solving for. And looking at this graph, I hope that you can see that you're going to have to solve for two proportions. You're going to do two different steps. The first step being the phase change here, and the second step being the temperature change here. So let's go ahead and label these. I'm going to call this Q1, and I'm going to call this Q2. So looking at Q1, I need to ask myself, which of the values at the top of your worksheet are going to be useful here? Well, this is a phase change from vapor to liquid. So the value that's going to be helpful is the heat of vaporization of water, which is 2,260 joules is required to phase change every 1 gram of water. So 2,260 joules for every 1 gram of water. So let's see how many joules we're going to need to change the 40 grams of water that I'm dealing with in this problem. So how much energy is going to be required? I'm going to remove how much energy in order to condense 40 grams of water. So if I cross multiply and divide, or cross multiply the 2,260 times 40, that'll be equal to the number of joules that I'm going to need to remove. And when you do that, you get 90,400 joules. And that's with the correct number of significant figures, that's rounded. So if I started with 104,000 joules, if I started with that many joules, and I will have used up 90,400 in order to move from here to here on the graph. Moving from here to here cost me 90,400 joules. So of that 104,000 that I started with, how much is going to be left? Well, I should have 13,600. So this is how much energy I have to remove to go from here to here. So I need to solve for the temperature change. I'm going to move to the next slide. Okay. So let's get sketch the graph again real quick. And we just found that the amount of energy required to move along Q1 is equal to 90,400. And I've just found that the amount of energy that I have left from the original amount that I started with, after I subtracted, I got 13,600 joules is what I have to use to move from here to here. So how far can I travel if I start here and move down, removing 13,600 joules? Okay. Well, which one of my numbers is going to be useful in this temperature range? Below the temperature of 100, water is in the liquid phase, and so I'm going to be using 4.18 joules for every 1 gram, 1 degree Celsius. I know that I'm going to be working with 13,600 joules. That's how much I'm going to remove. The mass stays the same. It's 40 grams. And I need to solve for the degrees Celsius. How many degrees are going to change? So when I cross multiply and divide, I find that degrees Celsius is going to be equal to 81.3. So this is how much the temperature changes. It's not the final temperature. So if I started at 100 and I change 81.3, I should get a final temperature of 18.7 degrees Celsius.